Okay, so for this one, find two independent vectors tangent to S at the point RU. So the two vectors that it's looking for are RU, which is going to be dr du, and RV, which is dr dv. So these are both going to be vectors, and we just need to do the derivative of r with respect to u and with respect to v. So here it's in a little bit of a strange form, but it actually makes it very easy to compute these derivatives. So the derivative with respect to u, right, these are constants, these go away, and derivative with respect to u is just 1. So this becomes 1/3, 1/3, 1/3. And we do the derivative with respect to v, so the derivative of this is going to be 0. Derivative of cosine is negative sine, and what we get is minus root 3 sine v, 0 plus root 3 sine v, plus derivative of sine is cosine. Cosine minus 2 cosine cosine. Okay, so we add those together and we get RV is minus root 3 sine v plus cosine minus 2 cosine v, and then root 3 sine v plus cosine v. Okay, find a vector normal to S at the point RU. So what this is asking for, it's asking for the normal. That's just going to be RU cross RV. So we do this cross product. That's not going to fit. I'm not going to try to fit it. I'm just going to kind of do it somewhat mentally. So we have 1/3, 1/3, 1/3, and then we have these things up here. So what we're going to get is, so for the I component, we have, cross this out, we have 1/3 times the k component, root 3 sine v plus cosine v, minus 1/3 times the y component, minus 2 cosine v. Okay, so that's the I component. The j component, we cross this out, so we get 1/3, same but negative. No, sorry, yeah, it's going to be the same but negative now. Sine v plus cosine v. And then minus, so that's going to be plus 1/3 times this. Which is going to be the same but opposite sign. So this is actually going to simplify to just 2 times this. Okay, and then the last one, we cross this out, so we have 1/3 times minus 2 cosine v minus 1/3 times the, let's see, so we have, it's going to be plus. Right, because 1/3 times this minus minus times that. Yeah. Okay. And other than just distributing the 1/3 um, and simplifying, this is going to be our normal vector. So let's go ahead and simplify this a little bit. I have 1 over root 3 sine v, and here I have 1/3 plus 2/3 cosine, so that's plus cosine. Here I have minus 2 over root 3 sine v minus 2/3 cosine v. And then finally we have minus 2/3 cosine v plus 1/3, so it's going to be plus minus 1/3 cosine v plus 1 over root 3 sine v. That looks strange. Let's see if I did these signs right. So this is positive sine. Okay, so that's that. This one, we have 1/3 this. Oh, I see. Okay, so that's not quite right. We have 1/3 times this minus, okay, so that's not quite right for sure. So let's actually write it out. So we have 1/3 times this minus minus 1/3 times this, the the I component. Okay, so the cosine terms actually cancel out, right? Because we have negative 1/3 plus 1/3. Yeah, so the cosine terms cancel out, so that shouldn't have been here at all. This is gone. And then let's check this, because I feel like that's slightly wrong. Okay, and then the k component, I have, cross this out, I have 1/3 times this minus 1/3 times this. This should be plus. Okay, yeah, so we have plus 1 over root 3 sine v plus cosine. Okay, that looks better, somewhat. What was the negative? Oh, hold up. No, that should be negative there, so that should be negative. That's better. Okay, now it says find the area. So now that we found that we need to compute the area. So the area is going to be the integral over s ds. Well, what is that? That's the integral over the region described by u and v. So it says u and v go from 0 to 3 and 0 to pi over 2. ds, well, what is ds in terms of u and v? That's going to be norm ru cross rv du dv. So let's compute the norm. So it's going to be square root, it's going to be a long, 1 over root 3 sine v plus cosine v, plus 4 over 3 sine squared v plus 3 sine v plus cosine v squared. We can insert page. Nope, I wanted to append page. Where am I at? There we go. Page, append. There we go. Okay, so to simplify, this becomes square root of 1 over 3 sine squared v plus 2 over root 3 sine v cosine v plus cosine squared v plus, we still have this, 4 over 3 sine squared v plus, now we have, okay, so this is still going to be 1 over 3 sine squared v, but now we have minus 2 over root 3 sine v cosine v plus cosine squared v. Okay, this looks like it'll cancel out nicely. So this cancels out with this. Here we have cosine v squared, cosine v squared. So it's going to be 2 cosine squared v. Here we have 1/3 plus 1/3 plus 4/3, that's 6/3. So that's going to be 2 sine squared v. So this simplifies to root 2 sine squared plus cosine squared is 1. So to compute the area, again, it's going to be the integral over s ds, and this translates into the integral over our region. So it says that u goes from 0 to 3, and v goes from 0 to pi over something, pi over 2. And then we're integrating the norm of ru cross rv, which we said was just root 2 du dv. So this is separable, so I can write this as root 2 integral 0 to 3 du integral 0 pi over 2 dv. So this becomes root 2 times 3 times pi over 2, which is equal to 3 pi over root 2. Okay, and next it says find or compute the integral of y dA. So what it actually means is compute the integral of y. What I meant to say was ds. Okay, because if we're integrating over a surface, we usually write ds, and dA means that our surface would be flat. So we've done all the hard work now. I can rewrite this as the integral. Again, I have 0 to 3, 0 to pi over 2. Now I need to write what is y in terms of u and v, but then the rest of this still stays the same. Root 2 du dv. So y was, okay, so this part I need to do some work. So let me copy this. So this was my function r of u and v. So let me rearrange everything and figure out what was the y component. So the well, I just need to figure out what was the j component. So I had a u over 3 in there. There's no j component here, minus 2 sine v. And this was my j component, the y component. Did I include that up here? I think I did. Yes, I did. Okay. Okay, so this was my y component. So this is what I'm going to put in here. So I'm integrating from 0 to pi over 2, 0 to 3. I can move the root 2 out in front, but I'm integrating u3 minus 2 sine v du dv. And I'll just split this up into two integrals. So this becomes root 2 over 3 double integral u du dv. The bounds stay the same, plus, or it's going to be minus now, minus 2 root 2 double integral sine v. And again, the bounds stay the same. Okay. This is separable, so this becomes root 2 over 3 times pi over 2 times u squared over 2 from 0 to 3, minus, this one's also separable, so we have 2 root 2 times 3 times integral of sine is negative cosine from 0 to pi over 2. These negatives cancel out, so that becomes a plus. So here, this becomes pi times 3 over root 2. All right, we have 9 over 3 over root 2. Isn't that what I had? Oh, yeah, okay. And then here we have plus 6 root 2 cosine of pi over 2 is 0. That's going to be minus 1. That's a 6 right there. So that one's a bit long, but there we go. Third question. Let S be the graph of sine x sine y, where x and y are in this range. Compute the flux vector of the vector field. Okay, so this is going to be our f. And what we want to compute is the integral over S of f dot ds. So what's different this time? Not much, but what's different this time is that now we have a vector function instead of a scalar function. So we're going to start off the same way. We're going to start off by finding our parameterization. So it kind of gives us r of u v. So it tells us what the height is already, right? This is our z component. So if we can just do u v and then f of uv. So that's going to be sine of u, sine of v. So I can compute ru, which is 1, 0. Derivative of sine is cosine sine v, and RV is going to be 0, 1 sine u cosine v. So I still need the normal. Let me say what we're going for here, though. So here, this is going to be equal to, we're going to integrate, just like before, we're going to integrate over d, f dot, instead of doing the norm, we're going to do ru cross rv dA. All right, so now we don't need to find the norm, we just need to multiply by this vector, or do the dot product with this vector. Okay, so this is going to be 1, 0, minus 1. All right, so I do the cross product, RU cross RV. That's I, J, K, 1, 0, 0, 1, cosine U, sine V, sine U, cosine V, and this becomes what? It's probably going to be kind of long, so let's give myself some more space. So we cross out the I component, we have 0. That's going to be cosine, or minus cosine U sine V. Cross this out, we have sine U cosine V, but it's negative, minus 0. Okay, and then cross k out, we have 1 minus 0, that's 1. Okay, now I need to do the dot product of f dot ru cross rv. So like we said, f here was 1, 0, negative 1. So what that gives me is this is equal to 1, 0, minus 1 dot this big thing here. So if I do the dot product, I get minus cosine u sine v minus 1. And this is what I need to integrate. And it gives us the bounds for u and v, right? It says, well, u, which is x, goes from 0 to pi over 2, or they both go from 0 to pi over 2. So integral over s of f dot ds, this is the integral from 0 pi over 2 of minus cosine u sine v minus 1 du dv. So again, I'm going to split it into two integrals, so to make life easy, 0 pi over 2, and bring the negative out in front, I have cosine of u sine v minus the double integral 0 pi over 2, 0 pi over 2 du dv. So this is just going to be the area of that square. So this is just going to be pi over 2 times pi over 2. So pi over 2 squared. This is separable, so I can integrate. This is going to be negative the integral from 0 to pi over 2 cosine of u du, integral 0 pi over 2 sine of v dv. So I start integrating. Integral of cosine is negative sine. I'll cancel that out here. So that's just sine of u from 0 to pi over 2 times integral of sine is negative. Wait, integral of cosine is sine there you go. Integral sine is negative cosine. That's where that negative cancels out. This is just going to be cosine v from 0 to pi over 2. Yeah. Minus pi squared over 2 over 4. Okay, so now we integrate this. So we get sine at pi over 2, that's 1 minus 0. And then we get 0 minus 1. So that's going to be minus 1 minus pi squared over 4 minus 1 minus pi squared over 4. Okay, so one thing I forgot to check that I should check real quick, and this would make a big difference, is if my tangent vector is going in the right direction. So here it says in the upwards direction through the graph. So basically my normal vector should, so if this is my surface, I have a surface, my normal vector should be facing up, not down. Right, we want the boundary of the surface, right? So we have u and v. We want this to be going clockwise or counterclockwise. So if this is u, this is v. So I just need to make sure that my normal vector that I got here is pointing up, and we see that the k component is positive, which means that the normal vector is indeed pointing in the positive direction. Okay, so that's fine. So the flux to the surface is this. And all that would have had the effect on is just the sign. The signs would have changed. Okay, so that's questions 2 and 3 from the review.